All right, welcome back. So in this video, I'm going to quickly run through the pseudocode for quicksort, but it's pretty short, so I'm actually going to just implement it too, rather than doing a separate video to show the pseudocode and then implement it, just to keep things a little briefer. So we have our pivot helper finished. We pass in a full array, or any array, and it's going to take the first item and figure out where it should go, and then put all the smaller items to the left, all the bigger items to the right, and then return the index. So that's important that it returns the index, because what we're going to do in our quicksort function is that it's going to call that pivot helper at the beginning with a full array. And we'll find out, the index of 4, for example, is the first pivot point. And then what we're going to do is recursively call the same thing, call quicksort again on the left side and on the right side of that pivot point. So imagine we call quicksort with this array. Well, the very first thing that happens is that we find the pivot, which is 4, and that is moved to this index right here. And then what we're going to do, there we go, is we're going to then call quicksort on this side from 3, the beginning, up until, but not including the pivot, because we already figured out this is in place. We don't want to move this. So we're going to sort the array here and here with quicksort. So the rough logic: when the helper returns the updated pivot index, we recursively call the pivot helper on the left side and then on the right side as well. Now it's important to notice, or to point out, we're not making new arrays. This is all happening in place. We're not making new arrays. It's happening in the same array. So our base case, it's not quite just to check if the array is item of length, or if the array has one item in it. It's to check if the sub array has one item in it. And what that means is we're always going to be working with this array, for example, but we're only going to be looking at this portion or eventually this portion. And so what we're going to check is not to see if the length of the array is 0 or is 1, because this length will always be the same. We're not adding or removing elements. We're going to check if the start point that we're looking at, and let's call it left and right, if the left and the right are equal to one another, or if the right is less than the left. So that happens when a subarray has less than 2 elements. So I'm just going to implement it. This is a tough one, honestly, to just take that pseudocode and try and write it yourself. I applaud anybody who wants to do it and who tries it out. But again, no expectation on my part that when I teach this in person, it's very rare that anybody can implement it right away. And even once I show the code, it can be hard to come up with it again. And I've already mentioned my struggles with it and how it's just unintuitive for me. So I'm going to define my function quicksort. I've already done that actually. And it's going to take an array. And the first thing that we'll do is call, so let's make a variable called pivot index. And it's just going to be equal to calling pivot with that array. But the thing is, our pivot, first of all, if we go back, it accepts an array, a start, and an end. And this is important because the very first time through, we want to call it on the whole array. But then this recursive function eventually is going to call it again on this subarray or this one, where we have a different start and end point. It's not just the default 0 up until the end of the array. So what I'm going to do is in here, I'm going to make an argument called left and set it equal to 0, and another one called right, which is array.length -1. And then we're going to pass in left and right when we call pivot. So the first time we call this right here, the default value for left is 0, and for right is going to be 0, 1, 2, 3, 4, 5, 6. So we're calling pivot on this array with 0, 6, right? So then that goes, I deleted a bracket, takes the first item inside of that pivot function, and it figures out that this needs to actually be at index 3. So it changes the array to look like this, and it returns the index of 3 to us. So pivot index is equal to 3 at this point. Then we want to repeat the same thing, but we want to do it on the left side, which basically means from the left, the start point, which right now is 0. So from the left up until the pivot index -1. So we already have this cemented in place. We want to now sort from here to here. And then the same thing on the right side, but we want to go from pivot index +1 up until the end, the right. So let's do the left first. So the left side is just quicksort of the array. This time we're going to pass in a left and a right. unlike down here when we called it the first time, they defaulted to 0 and then array.length -1. This time the left that we're looking at is still going to be the same left that we looked at before, 0. But next, the right, where we're going to stop, is going to be what we've already discussed, the pivot index -1. So that way we don't include that pivot index in there. So this is cemented. We just want to look at that. And the same thing on the right side. Well, not quite exactly the same idea, but it's going to be quicksort of the array, but we're going to start at pivot index +1. So that means if this is our index, we want to go from here until the end. So pivot index +1 until right. So those are the recursive calls. However, if I just run this as it is right now, there's a big problem. It's going to run forever. So actually, if I do this, we get our Stack Overflow maximum call stack size exceeded, because there was never a base case. Nothing was ever returned. Nothing ever stopped this recursive call. It just keeps going and going and going and going and going. So where do we want to stop? We want to stop in this situation, or this situation, where we've hit a subarray that is 1 element long. And how do we know that? Remember that at any point, if we looked at array, it's always the entire array. We're sorting it in place. So even at this step right here, for example, array is still the entire array. But what has changed are left and right, because left and right are constantly changing as we're calling quicksort recursively, because left and right are based off of the pivot index. And so we're getting a new pivot index each time. Left and right are changing. And so as these subarrays become smaller, left and right get closer together. So for example, here, left was 0 and right was 6. Then here, for example, left was 0 and right was 2. Here, left is 0, right is 1. Now here, left and right are the same. So our conditional, we want to keep doing this code, keep running if left is less than right. And so as soon as they are equal, as soon as left is now equal to right, that means that we're looking at 1 element. Does that make sense? Remember that left and right are just pointers inside of this full array. So it started like this, and then on one of them, the recursive call moved to this, and then to this, and then they became the same thing, and that's when we stop, because that means that we've hit the end, at least of one of the branches. So I need my bracket there. There we go. Okay, so we're still not quite done. We have one missing piece, which is really important. We're not returning anything. We need to return array at the very end. Because remember how these recursive calls work. This quicksort here is waiting on the results of quicksorting this and quicksorting that. And then those in turn are waiting on the result of quicksorting this and that. So we have to return the array here so that we can get it back here and keep going up. And then the same thing on the right side. So let's save, and I'm going to clear my console. Let's see if it works. Nope, not clear 0. There we go. Let's see if it works now. And it looks good. We're getting 1, 2, 3, 4, 5, 6, 9. Not sure why I chose that. And let's just verify. Let's mix it up again a little bit, put a negative number in here. All right, and it looks like it's working.